In this video, we're given the first three terms of a geometric series are x minus 8, x, and 2x plus 12. For part A, we want to find the possible values of x and the common ratio of the series. And for part B, we're told one of the series is a sum to infinity, and then to find this. So if we look at part A first, we want to find the possible values for x and the common ratio of the series. Well, it's a geometric series and we're given algebraic expressions for the first term, second term and third term. So let's look at what the definition of the common ratio is. Well, we can either do the second term divided by the first term, or alternatively, because we have the first three terms, we can also do the third term divided by the second term. Well, we can substitute in our expressions for the first, second and third terms, and we can say that we have x over x minus 8 is equal to 2x plus 12 over x. We can rearrange these algebraic expressions and solve such that x squared is equal to 2x plus 12 times x minus 8. If we expand the brackets, x squared is equal to 2x squared minus 16x plus 12x, which is minus 4x, plus 12 times minus 8, minus 96. Move the x squared over. X squared minus 4x minus 96 is equal to 0. At this point we have a quadratic expression which we can then factorise such that x minus 12 times x plus 8 is equal to 0, and therefore x is equal to 12, x is equal to minus 8. Now that's the first part of A. We've found the possible values for x. We still need to find the common ratio for the series, and because there are two values for x, we're going to generate two values for our common ratio. Now, we can use either expression for r, but the first one's probably the easiest. You can always check it with the second. So using r is equal to x over x minus 8, when x is equal to 12, this implies r is equal to 12 over 12 minus 8, which is 4. So therefore r is equal to 3. When x is equal to minus 8, r is equal to minus 8 over minus 16, which is equal to a half. So we found our corresponding r values for our possible values of x. And therefore we've finished part A. Part B then says one of the series has a sum to infinity. Find this. So if we have a sum to infinity, that tells us something about our geometric series. For it to have a sum to infinity, it must converge. So the geometric series converges. And if that's the case, we know that our r value is trapped between minus 1 and 1. So from our two values for r, that implies that r must be equal to a half for our series with a sum to infinity. So we have a value for r. In order to use the formula for the sum to infinity though, we still need to get a value for a. Well, we have an expression for a. So a is equal to x minus 8. And when r is equal to a half, that implies our x value is equal to minus 8. So minus 8 minus 8, a is equal to minus 16. So a is equal to minus 16, r is equal to a half. If we substitute those into our sum to infinity formula of a over 1 minus r, we have minus 16 over 1 minus a half. 1 minus a half is a half. Minus 16 divided by a half becomes minus 32. So our sum to infinity is equal to minus 32. And that's how we solve this problem.